So I want to explain, I'm going to go like a little bit more into depth on something like 4, especially to talk about the domain restriction. There are 2 ways to do number 4. One is to find f of g of x and then plug in the -1. So I could take f and plug g into it. So I would take this and I would plug it into here and I'd get 3x squared minus 4 minus 1. That is f of g of x, right? I take the g of x and I plug it into the f of x. And then I could distribute it and I could combine my like terms, go all the way through.
So you don't just multiply them?
No.
When it's f of g of x?
Correct. I could do that. That is just f of g of x. So if I wanted to find f of g of -1, I can first find f of g of x and then plug in a -1. And get my answer. Or I can plug -1 into g, which is what I did on the video. -1 squared minus 4, which is 1 minus 4, which is -3, and then find f of -3. Either way, you get the same answer. I think second method is less confusing, but you get to choose. So because you can do it both those ways is why we have to account for a domain restriction from the beginning. So if I was asked for the domain of f of g of x, I have to look at the one I plug into first because that's what I can do. I could literally plug it into that first one and then plug it into the second one. And I have to look at the domain restriction for the composite function because my other option is to make it composite and then plug it in like this way. So because you can do it both ways, when you're dealing with a composite function, you have to look for the domain restriction on the first one, the one inside, so the one on the right, the one that you plug into first, which would be whatever's on the right, whatever letter's on the right. You have to look at that domain restriction, and if there is one, it gets carried down. And then you have to look at the composite one, and if there's a new restriction, that also gets carried down. This example, both of them were all real numbers, so it didn't matter. But let's just say you had a domain restriction on g of x. It would carry down into the composite function. And every other question that used g of x would also have that. Does that make sense?
And you would put it with a union.
And you would, so if it's 2 and you have to figure out where it overlaps. Yep. If it's just like it can't equal 3 and it can't equal 2, then it would be -infinity to the smaller one, so 2, then 2 to 3, then 3 to positive infinity. I just want you to understand that because people like have a gap there and they don't understand why. Why am I bringing this down only for the one you plug into first, right? Only for the one on the right. But that's why, because you can do it both ways. You can either plug the number into the composite function after you combine it, or you can plug it into the first and then plug that number in. So this has no domain restriction. It would be -infinity to positive infinity. For all of it, because they all used one. Well, no, not for all of it. Sorry, number 3, where it put it in the denominator, there's a domain restriction.
And 4 and 5, right?
No, because 4 and 5, there's no fractions. Yeah,
So it is all real numbers.
it's all real numbers. Oh, I'm sorry. I thought you were saying that there is a restriction on 4 and 5. No, 3 was the only one that had an answer other than -infinity to positive infinity for the domain.
Wait, can you work on it?
Number, yeah. So you're fine on the setup, like putting f of x over g of x. It's 3x minus 1 over x squared minus 4, right? So the originals, neither of them had something in carry down. They would have both been all real numbers, so I don't have to worry about that. But my new one put a variable in the denominator, and the denominator can't be 0. So I would say x squared minus 4 cannot equal 0. And then you can either different to 2 squares that, solve them, or use the even root property, move the 4 over, square root it, but you have to put a plus and minus there.
But how do you know if the A is composite in the middle?
Yeah, in the middle.
So the order of interval notation, if it's a not equals, right? So this says x cannot equal -2 and x cannot equal +2. It's all the numbers less than the smaller number, which is -2. So I go -infinity up to -2. It can't include -2, so it gets a parentheses. Then it's all the numbers in between -2 and 2, And that's how we show that, -2 to 2. And then it's all the numbers bigger than 2, so it gets a parentheses on 2 to the right.
What would happen if one of the original had a domain? Like,
So let's say, let me try to figure out.
only use G? Like, is G the only one that matters?
No, in the composite functions, in the f ofs and the g ofs, in these, you only worry about the second letter and then the end. For anything else, you have to use anything from the top. So let's just say f of x was 1 over x and g of x was x plus 4. And let's say it was f plus g of 2. There's 2 ways to do that. One is find f plus g first, which is 1 over x plus 4. And you can't combine, you could just leave that as it is, right? Because you'd have to find a least common denominator to combine it. That gets messy. You could literally leave it as it is. And then I can plug 2 in. 1 over 2 plus 4, which is 1/2 plus 4/2 plus 8/2 or 13/2. So for that one, I added the expressions first and then I plugged the number in. Or I could do f of 2 plus g of 2. So I'd get f, which is 1/2, and g, which is 2 plus 4. I get 1/2 and 6. 1/2 plus 6, which is 12 and 13 over 2. So you can choose which way to do it. I would recommend this method. I think this is easier, okay? But in a plus, it's not that big of a difference, okay? Now, because I can do both of those, I have to worry about the domains separately. I have to come back and say, okay, what is there a domain on F? Is there a domain restriction on G? Because that gets carried down. Is there a domain restriction on my combined one? Was there a new one brought in? If that's the case, then all of them get combined. I have to worry about all of them. So because on F, what's the domain restriction on F? Can't equal 0, right? So x cannot equal 0 comes from just the f of x. Is there a domain restriction on G? No. Is there a domain restriction added into f plus G? No, we didn't add anything. It's the same one that got carried down already.
Because you just had them.
Right. If it was f over G, now you're doing a fraction over a thing, keep, change, flip, you're going to add in a new denominator, and that's going to make it a new restriction.
So always in adding, usually you won't have a new domain restriction, or you just have to tell.
It's usually with a new one comes usually with the fraction. Yeah.
But the only one you have to go back to the originals for is like multiplying.
And adding.
No, anytime you use it. It won't always ask for domain restriction. If it asks for domain restriction, then you have to look at them. Yeah.
If after domain restriction, it's just for, like, you go back to the original only for multiplication.
No.
And adding. We just added right now.
Yeah.
So all of them go back to the original.
Usually.
And then if it's, and also, is there a new one if you combine them? Yeah. The only one that does not go back to the original is the composite function. You don't have to go back to the original and the number on the outside. Because you're never plugging into the number on the outside without having already plugged into the one on the inside. Does that make sense? I don't want to spend too much time on this. This is such minute detail in terms of all of it. Okay, but I would love for you to understand the why in order to understand the domain. Okay, 1-6 is inverse functions. So this is the last section we're going to cover from. All right, so again, 1-6 is inverse functions. We're all open now, yes?
Yes.
Okay. So what is an inverse function? Okay. The inverse function to another function is one in which when you find the composite of those two functions, everything would cancel out except x. So if I have two equations and it says is one the inverse of the other, I would find f of g of x and g of f of x. Is still not working?
No, my iPad's
All right, so the other thing from this slide you need to know is that we show that something is an inverse with the little f negative 1. So if you see f of x, and then you see f negative 1 of x, this means the inverse to the original function, okay? So it might just say, here's f of x, find f negative 1 of x, and you need to know that that means find the inverse, which I'm going to show you how to do, okay? Or it will literally say the words find the inverse, okay? But f of x and f negative 1 of x are inverses of each other, okay?
So that means the same thing as f of g of x?
No, this is the test to see if they're inverses. So if these are inverses, then I can take f negative 1 of x and plug it into f of x, and I should get x as the answer. And then I can take f of x and plug it into f negative 1 of x, and I should get x as the answer. So if they are inverses, when you make the composite function in either direction, you'll always result in an x. And that's the first thing we're actually going to do. So this says use the inverse function property to show that f and g are inverses of each other. So f of x is equal to x minus 6 and g of x is equal to x plus 6. It doesn't mean every inverse you just change that sign. That's not the way this works, okay? So don't do that because people do that. I'll teach you how to find the inverse. But this is a test. It's already telling you that these are inverses. Your job is to prove it by doing f of g of x and then doing g of f of x. So it has to work both ways in order to prove that these are inverses. So the first one, I'm going to take the g of x and I'm going to plug it in to f of x. So I get x plus 6 minus 6. The negative 6 and positive 6 cancel out. And I get just x, which is what I wanted. Yep, so I have to find f of g of x. I have to take g of x and plug it into f of x. So g of x goes into f of x. Then g of f of x is the reverse. I have to take the f of x and plug it into the g of x, and I get x minus 6 plus 6, and those cancel, and I get just x.
What are you looking for?
This is verifying that they would both result in x.
So they have to be like equal the same.
They have not the same. They both have to both be x.
X. Okay.
Yep.
So this one is inverse?
They are. And the directions tell you that they are this time, so your work is the proof on this. Does that make sense?
Yeah.
Yeah. I'm going to show you how to find it, where you only get one and then you have to find it. But this right now is just the proof, which means if you do get asked to find the inverse, you can check your work by finding the composite functions, and they should cancel out. Vicki?
So you were just writing it down.
Yeah, the work is literally your answer to this question. Yeah. All right. B says f of x equals x squared minus 3 and g of x, and I don't know why that's space, but that huge space, square root of x plus 3. We're going to ignore these for right now. I'm going to talk about them later, why those are there. But for right now, we're going to ignore them. And then again, you'll understand them. I'll come back to it. So I'm going to find f of g of x. And I'm going to find g of f of x. So the g of x is going to get plugged into the f of x. And I'd get the square root of x plus 3 squared minus 3. What happens when you square root? Goes away. I get x plus 3 minus 3. These cancel, and I get x. So far, so good. Then I go to the next one, and I'm doing the reverse. Take the f of x this time and plug it into negative x. I'm sorry, and plug it into g. So I get the square root of x squared minus 3 plus 3. These cancel. Square root of x squared. Square root and squared cancel, and I get just x. Now in technical rules, it's the absolute value of x, which is where that domain comes into play, but we're not going to worry about it just yet. So I'll be really transparent. This is not a test or quiz question. This is how you use it to check your work, okay? This is what you're going to be tested and quizzed on. How to find a function if you're given one. So if I give you an f of x, and I say find the inverse, did I say find the function? Find the inverse. You're going to, step 1, replace f of x with y, because those are the same things. Step 2 is switch x and y. Everywhere there's an x, I change it to a y. Everywhere there's a y, I change it to an x. Then we work to solve for this new y. And then we replace y with f negative 1 of x, showing that we just found the inverse.
And will it give us what f
Yeah.
negative x?
Oh, no, not f negative 1. That's what you have to find. It will give you f of x. Then we're going to find it, and then the very last step is to replace it. It's important to replace y with f of x because we changed our equation's value by switching the variable. So it's not the same equation. You can't leave it as y. All right. A. So A says, find the inverse, right? So I'm going to take f of x, step 1, replace it with a y. Yeah, that's why we can replace it. We're just rewriting it in a different way. No, but now we're going to switch the x and the y. So now an x becomes a y and a y becomes the x. So this is x equals 7 minus 3y. We have now changed the value of this equation, which is why we can't leave it y equals at the end, right? We didn't just move it around. We literally changed it by swapping the x and y's. Now we solve for our new y. So I'm going to subtract the 7. I get x minus 7 equals negative 3y. And I'm going to divide by negative 3. And I get y equals x minus 7 over negative 3. I can leave it that way if I'm just trying to find it. I'm going to still change the f negative 1 back, but I could leave it that way. If I'm going to graph this, I'm going to make sure I split that up. So it's negative 1/3 x plus 7/3. So you could be asked to graph this, and in that case, you have to write both. You'd have to write it the second way. I just split it. I split it into 2 fractions and divided them both by negative 3. I had to divide it over here because it was attached to the y.
No, I mean the negative 1/3.
So
Sorry.
it would have, if I took this fraction and I split it, right, I would have had x over negative 3 and negative 7 over negative 3. Both of these would get a negative 3, right? This would go with this and this would go with this.
It would be 7/3 plus x.
It could be, but then that's not in y equals mx plus b form. Yeah. No, it would be 7/3 minus x over 3.
Where'd you get
You
the
can't
negative?
split this. Like, I can't do that. That 3 goes with both.
Oh,
Yeah.
I see.
Why wouldn't it be negative 1/3 x minus 7/3?
Because, okay, so let me go back to this step here. Okay, if I divide this side by negative 3, I have to divide each of these by negative 3.
Oh, yeah.
Right?
That,
So negative x over 3 could be the negatives in the front. The negatives in the top, negatives in the bottom, doesn't matter, just one negative. But this is a negative 7 and a negative 3, so this is positive. Yeah.
so that's if they ask you to graph it.
Or you just want to split it up. It's not wrong either way. Like WebAssign would take this answer and also this answer. Yeah. But I'm not done. Remember the last step is what? Negative f, negative 1. You have to switch it back because it is not the same equation anymore. We changed it. So I could either write that or I could do the one where they're combined.
Both of those answers would be right.
Correct.
You only changed the y to negative 1 of x, right?
Yes. Not the x. Yes. Yep.
It could be either of those.
It could be either of those. If it's asking you to graph them, I would expect to see it split. But WebAssign will take both. As would I if it was an open-ended question. All right, we're going to do the same thing with B. Y equals 1 over x plus 2. Switch the x and the y. Solve for the new y. What do I do? You can multiply both sides by y plus 2. Distribute the x. And then I want to get y by itself. So I'm going to move the 2x. and then divide by x. That answer is totally fine as soon as I replace this back with a -1 of x. Or you could split it. When you split it, these x's cancel. So you could also write it as 1 over x minus 2. All of those are acceptable answers. Okay. How to graph an inverse. So now we're going to graph these. It's going to give you one, whether it's a set of coordinate points or it's going to give you the equation, and we're going to graph its inverse. You literally just have to switch the x's and y's. So if it gives you x coordinates and y coordinates and it says graph this inverse, the x's become the y's become the x's. Just like we just did with the variables in the equation, you just switch them, okay? The other question is going to ask you, is something an inverse? Or does it have an inverse, sorry, which is the same thing as saying, is it 1-to-1? So the verbiage on this confuses people, okay? If a function is 1-to-1, then it can have an inverse. If a function is not 1-to-1, it can't have an inverse. There's 3 checks for 1-to-1. Just like there were 3 checks for if it was a function, there's 3 checks for 1-to-1. The first is the x values can't have the same y. I'm going to rewrite this in the verbiage that we used for functions because I think it's easier. So this time the y cannot repeat with a different x.
The slide right before, this only applies to graphing it, right?
So again, the y can't repeat with a different x, right? So the test for function was that the x couldn't repeat with a different y. This is the reverse. Now the y can't repeat with a different x. And we use the vertical line test to test for function. We switch it now and we use the horizontal line test. If a horizontal line hits your graph at more than 1 point, then it is not 1-to-1 and it cannot have an inverse. So all the tests we did for functions, we flip-flop, okay? Look at these examples. So it says determine if the graph is a function. If it is a function, is it 1-to-1? And if it's 1-to-1, graph the inverse. So there's 3 parts to this. First is it a function? How do we test if a graph is a function? Vertical line test. Is it a function is vertical? So look at A. Is this a function? No. I'm done. Yay. I don't go any further. Go to B. Is this a function? Yes. So part A is it is a function. Second part says, is it 1-to-1? Now that's our horizontal line test.
Wait, is it third function?
Yeah. Is this 1-to-1? No. So I did one step, but I'm now done. Not 1-to-1, which means it doesn't have an inverse. Go to C. Is it a function? Yes. Is a function. So function, yes. Is it 1-to-1? Yes, which means it does have the inverse. Now it wants you to graph it. So let's pretend that these are on a number grid. And we can find these coordinate points. That's really bad spacing. So I just made up those points, okay? Do the same. Like if it's on a number grid, you're going to actually have them. But if not, you're just going to find them. How did we say, what do we do with points to find the inverse? Switch the x and y. So if our original ones are -3, 0, and 1, 2, what's the inverse? 0, -3, and 2, 1. So I go 0, -3, plot a point, 2, 1, plot a point, and I draw my inverse. Vanessa. Yeah, it will normally, like if I want you to be precise, that will be on a number. It will actually be on a coordinate grid that you can plot those points. Okay. The other way to do it is that you flip it over the origin, or over the y equals x line. So if I didn't, it's reflexive to the origin. If I didn't have points, I could also imagine the y equals x, fold it in half, and it should reflect over it. So these would be symmetric to the origin, the two of them combined.
B didn't have horizontal.
It would fail the horizontal line test, so it's not one-to-one, so you can't do the inverse. So when you're determining if the function has an inverse, this is simply a yes or no question. A would be your domain and your range. So x, remember, domain is the x and range is the y. And the y can't repeat with a different x. So this y only links with this x, but this y links with both this and this. If it's hard for you to see it that way, feel free to write out your ordered pairs. So 1 would go with 80, 2 would go with 80, and 3 would go to 100. And this y repeats with a different x, so this is a no. You actually need to go ahead and change the last one to be a -1, -3, and I'll explain why in a second. So this says if the function has an inverse, it's already saying it is a function, you're just testing for the inverse. So you can look directly at the y's and see if they repeat with a same x, or with a different x. The y's are already different, so this is a yes. Now if you had left it the way that it was before, this actually fails my function test. So it's not a function, and if it's not a function, it can't be one-to-one. So this needs to be changed to be the -1 to be consistent with the directions. Real quick, and then I'll do that last example. The third test to see if it is one-to-one, which means it can have the inverse, is from an equation. So remember, function test was that the y couldn't be an absolute value and the y can't be raised to an even power. Now it's the x. The x cannot be raised to an even power or be inside an absolute value. If you think about what those would look like, it would be a parabola, or an absolute value would be a v, and those would both fail my horizontal line test. Does that make sense? Yeah. So these are not one-to-one, which means they don't have an inverse. Okay, then determine if it's a function from the equation. Remember, the x cannot be an absolute value, and the x can't be raised to an even power. A is yes, B is no, C is yes, and D is no. That wraps up the notes for 1.6.